All right, welcome to day 4 of Unit 12. We are going to be kind of flipping the script today. Our last 3 videos focused on how to graph given an equation, but today I'm going to give you the graph and you have to tell me the equation. So what that means is for us to be able to write the equation of a graph, I'm going to be looking for certain key features. The first thing is whether or not it's a sine or a cosine curve. So remember that sine always starts at the midline. Okay, so it could be shifted up or down, or it could be right on the x-axis, but sine will always start on the midline. Kind of rhymes a little bit. Cosine actually starts at the amplitude. So remember, your amplitude is always positive, but if your leading coefficient is negative, it will start at the reflected amplitude. You could also maybe look at one full cycle, and if it starts on the midline, one full sine cycle should look like the letter S, whereas one full cosine, and I know this is kind of weird and abstract looking, but if you think of that and look at it sideways, it kind of looks like a C shape. That is cosine. Some other people say it looks like a valley or a ditch or something like that. All right, so that's going to be the first thing that we look for is whether it's sine or cosine. Once we determine if it's sine or cosine, the next probably easiest thing to figure out is what is the amplitude. So the first thing we find is what type of function. And then what is the amplitude? Remember, the amplitude is the distance from the midline to the maximum or the minimum point, but it is always going to be a positive value. However, sometimes it is reflected. So is the coefficient going to be positive or negative? So look for reflection. All right. Maybe we would then figure out our midline. That actually might be more beneficial to find before we do the amplitude. Remember, the midline is halfway between the maximum and the minimum point. So if we have a curve, if we have some curve here, here's our maximum, here's our minimum, and our midline should be right down the center. Such a good drawer, yes. All right, our frequency is how many curves we will see between 0 to 2 pi. So there could be one, there could be multiple, there could be half. So we're going to have to really be able to look and see how many full cycles we see. And then last but not least, we're going to pull it all together. So the standard form for a sine curve is a sine bx plus d, or a cosine bx plus d. All right, it is time. So, very first example, we're going to start off with a very easy first example. Let's read the directions. Write the equation of the graph shown as a sine, that should say, or cosine curve. Each graph uses the intervals 0 to 2 pi with a scale of pi over 2. Great. All right, so that means this curve is ending at 2 pi, just the way we like it, and the scale is counting by pi over 2s, which also is exactly the way that we want it to look. So, looking at this curve, it starts on the midline and ends on the midline, so I'm going to say that that is a sine curve. It appears that the amplitude hits a value of 2. It appears that it also goes down to a negative 2, so that means our midline must be at 0. And I see one full sine curve, so our frequency is 1. It is not reflected because it goes positive first, so that means we have a positive leading coefficient. And so when I write my equation, it's y equals the a value, our amplitude, sine of 1x plus 0. Now there is always somebody in the class that tells me, do I need to write the 1 and do I need to write the 0? And my answer is going to be No, absolutely not. So if you would like to just write y equals 2 sine of x, that would be just as sufficient as writing it with all of the things. All right, let's do another example. I'm over here changing my colors around and stuff. All right, so we are starting on the midline again. And we get to go up, and then it ends on the midline. Weird. Well, if this doesn't seem like a full curve to me because it didn't go below the midline at all. Notice that there's no curvature to it. It just looks like part of the one above it. So that must be a sine curve. My amplitude is going up to a height of 3. But the question is, how much of a curve am I seeing here? And I think if I extend it out underneath like I have here, it's a little bit more obvious that we are only seeing half of a sine curve. Our midline, it's hovering above and below y equals 0 again, and it is not reflected because it went up first. So when I write this out, my equation would be y equals 3 sine 1/2 of x, and if you want to put the plus 0 on the end, you may, or you can leave it off. I'll go back to my red. Ooh, this one looks fun. All right, so let's ignore, I'm going to change my color. I'm going to completely ignore this side of the graph. I am only going to try and focus on the y-axis. So try and narrow down your focus here and only look at what happens on the y-axis. And I see, maybe I should use a different color. I see from here that the graph is not hovering the x-axis anymore. It appears to start on the midline, go under, go above, and then land back on the midline. So that is going to be a sine curve. However, its amplitude from that midline that we just noticed has been shifted, it only has an amplitude of 1 box. So 1 box, our amplitude is 1. Our frequency is, remember, the number of curves we see by 2 pi. So we just saw 1. Here's a second one. So that means we have a frequency of 2 full curves. Our midline, if you can see underneath my scribbles there, is y equals 2. But look at the first sine curve. See how it goes down first? That means it was reflected. So when I write my equation, this one's got a lot. I threw a lot at you in this question. Y equals a reflected, so -1 sine. Our frequency was 2, and our midline goes shifted up 2. So that one had a lot going on in it. So you always want to base it off of the y-axis. That's why I did all that scribbly stuff on the left-hand side. You always want to look at, starting at the y-axis, what is the curve looking like? All right, let's try number 4. Number 4, switch my color again. Number 4 appears to start below the y-axis, or I'm sorry, below the x-axis. Then I work my way up and hit a maximum point, and then I work my way back down and end under the midline, or under the x-axis. If I am starting below at -2, that is going to be a cosine curve, but reflected, because it starts at a negative value, so that means it would have a negative coefficient. The amplitude is 2. This is still following the same instructions that you were given on the previous page here. So I know that this ends by 2 pi. So that means I'm seeing 1 full curve by the time I get to 2 pi. My midline is still at 0. So when I write my equation, I have a reflected cosine curve with an amplitude of 2, a frequency of 1, and a midline of 0. So if you don't feel like writing the 1 and the 0, you could just write this. But I would accept either answer. Okay. Sine or cosine? That's always your first question. So does it start on the midline or does it start above or below it? This one starts, and I know it's a little pixelated, but it starts right there on the midline. One full cycle stops right there. So this is a sine curve, but notice it goes under first, so that means it's reflected. And it goes to 1, 2, 3, so my amplitude is 3. Frequency is how many curves? So we already counted one. That one's a second curve. There is a third curve. So there are 3 sine curves here. Our midline is still at 0. So when I write my equation, it is y equals a reflected amplitude of 3 sine. Frequency was also 3, and then it was shifted nowhere, plus 0. Okay, number 6. Oh, there's definitely been some shifting happening on this one. It might actually help us to figure out, okay, so if the highest it goes is -1, and the lowest it goes here is -3, then let's draw in a nice midline dashed line there to help us see that. All right. Go back to my pen. Did I select it? Yeah, okay. All right, so we are looking at, all right, it starts at here, above our midline. We go down and we come back up, and it ends by the time we get to 2 pi. So that is one full curve. That is a cosine curve because it starts above our midline. Our amplitude is this height, which is only a 1. Our midline, we said, what got shifted down 2, and it is not reflected because it starts above our midline. So y equals 1 cosine 1x minus 2. Or if you don't feel like writing all those ones, you can just write cosine x and then a minus 2. Great. All right, well, what if I change the scale? So all of those have been very generous to us in the fact that all of them had a scale from 0 to 2 pi. If you hear my dog grumbling in the background, just ignore it. But what if the scale isn't from 0 to 2 pi? So let's take a look at this next example. The next example, I hope at this point you all agree that it's showing a sine curve. However, it's only going until pi. The amplitude is easy to figure out. That goes up to 1. But the frequency might not be as straightforward as before. I noticed that there are 2 curves by the time I get to pi. All right, so by the time I got to pi, there were 2 curves. Remember, frequency is always based off of 2 pi. So how do I get from pi to 2 pi? I multiplied by 2. So if I multiplied that by 2, then I would have to multiply this side by 2. So that means if I extended this out 1, 2 more times, I would see 4 total curves by the time I got to 2 pi. Okay, so I'm going to be doing this little chart here, kind of off to the side every time my axis is not in terms of 2 pi, but something else. This one, it went up positively on the first kind of, I don't know, whatever you want to call it, hill of the sine curve, so it is not reflected. So this is y equals an amplitude of 1, sine, a frequency of 4, and then there was no midline on this one. All right, so let's try a couple more of those where we have to kind of look out and see what the scale is giving us in terms of. All right, so sine or cosine? pretty easy to determine. It starts way down here, so starts and ends at a minimum, so it's a cosine, but it is reflected because it starts negatively. And it actually starts at -3, so that must mean the amplitude is 3, but the frequency, that's what we have to figure out. There is one curve, there's one curve in the distance of 4 pi. I want to know how many curves will then be shown by 2 pi. So to get from 4 to 2, I have to divide by 2. So 1 divided by 2 is a half. So that is going to be my frequency. And actually, I feel like that kind of makes sense. If this is 4 pi, okay, if this point here is 4 pi, then halfway would be 2 pi, right? So it's almost like this second part of the graph doesn't exist, and how much of a cosine curve did I see? I see only half of one. All right, let's try another. Let me use green this time. All right, question number 1, sine or cosine. So it starts on the midline, goes up, it goes down, and it stops back on the midline. That is textbook sine. It makes an S. It has an amplitude of 1, 2, 3, 4. So amplitude is 4. It is positive. It goes up first. Okay, it makes a hill first instead of a valley first. So it is not reflected. And then here we go, frequency. So I see 1, 2, 3. I see 3 curves by the time I got to pi. I want to know how many curves would that be to get to 2 pi. So to do that, I multiplied by 2. If I multiply this side by 2 as well, then that would be 6 full curves by the time I get to 2 pi. Oh, silly me. I just realized I never wrote the equation for the last one. So let me write this one. It would be y equals 4 sine of 6x. Let's go back to the other one. Let me change back to blue. This would be y equals 3, negative, because it's reflected, cosine of a half x. So sorry about that. I never wrote the equation. All right, last one here. Let me do my third and final color. Sine or cosine. So it starts at a maximum, ends at a maximum. That is textbook cosine. Amplitude of 1. It is positive, so it is not reflected. All right, I see one curve by pi over 2. I want to know how many curves is that in 2 pi. So remember, pi over 2, if you forgot, it's okay. Remember, pi over 2 is 90 degrees. Remember, 2 pi is 360 degrees. So if I am seeing one curve in 90, how many times does 90 go into 360? Well, to get from 90 to 360, you have to multiply by 4. So if I see one curve by pi over 2, then I would see 4 curves by 360. And so my frequency is 4. So y equals 1 cosine of 4x. All right, so that should be enough to help you out with your homework tonight. You have a couple of those. Just be careful and watch what your scale is in terms of. If your scale changes and it's not in terms of 2 pi, you should probably do some type of little chart to help you figure it out, unless you've got it down. All right, I'll see you next time.